So what we have done so far is we have talked about the faster processes of breakdown, the faster mechanisms by which breakdown happens in solids. However, not always we are concerned with just the short-term breakdown mechanism, but we are more often than not concerned with the long-term breakdown mechanisms, because long-term breakdown mechanisms can cause breakdown of a solid insulation in service even under normal operating conditions. So we have talked about intrinsic, which is kind of property of the material, then avalanche mechanisms. So intrinsic and avalanche mechanisms are electronic mechanisms through which breakdown happens in a very short time. Then we have the electromechanical process, where electrical forces, electrical stresses cause mechanical rupture of the material. And lastly, we have talked about thermal failure. Thermal failure is the most common mode of failure in power apparatus. Lastly, we come to erosion and electrochemical process. So if you look at the time scales here, you can see that we are looking at much larger time scales in the order of range of above 10 to the power 4 seconds. So several hours. In fact, we are looking at processes which take a very long time. And when I say very long time, it means several years at times to develop and cause breakdown. But it is of concern because, as you can see, as the time increases, the breakdown strength increases, which means that there might come a certain time after an apparatus has been in service for a considerable number of years, it might so happen that normal operating stresses can drive it to breakdown. And the processes which cause long-term breakdown are very different from the processes that we have been discussing, and principally these are erosion and electrochemical processes. Let us see what we mean by that. The first process is really an electrochemical process involving some erosion, and this process is called tracking. Remember, tracking takes place mainly on the surface of an insulator. It does not take place through the surface, but it takes place it does not take place through the volume of the dielectric, but it takes place on the surface of the dielectric. And therefore, tracking is of concern mostly in case of outdoor insulators. Tracking is the formation of a permanent conducting path, usually carbon, across the surface of insulation. Now, if you remember, we have talked about volume conductivity and we have talked about surface conductivity. We are also concerned about the surface conductivity of our insulators because there may be considerable conduction of current from one conductor to another conductor across the height. So there might be considerable conduction of currents from one electrode to the other, not only through the volume but along the surface of the conductor. And how much conduction there would be depends upon the surface properties, the surface condition of the surface of the dielectric, also the ambient conditions. So actually, we must remember that when we talk about breakdown of solids, there are two kinds of breakdowns that we can talk about. One is the puncture, where there is a conducting path which is created through the volume of the channel, bridging the two electrodes. So through and through, there is a channel through which current can travel and short circuit happens. The other possibility, especially in case of outdoor insulators, is when there is a conducting channel formed along the surface of the conductor. So if these are your two electrodes, the high voltage electrode and the ground electrode, there might be a conducting channel from along the surface of the dielectric from this point to here, and you have a short circuit along the surface of the conductor. This is called flashover. This, of course, generally the flashover voltage is much lower than the breakdown voltage or the puncture voltage, because we are not just dealing with the dielectric material, we are also dealing with a path along the surface of the dielectric, and which is on the surface of the dielectric you have gases or air. Now, we talk about tracking mainly in terms of outdoor insulation. Now, when an insulator is in service in the outdoor environment, what would happen is there would be contamination of the surface. There would be a large amount of pollution that might be just in pollution from the environment, but it could be also other. For example, if it is an industrial region, there would be a lot of oil and grease and dirt particles. In the desert, it could be dust, it could be sand. In a city, it could be dust particles. In the coastal regions, it could be salt. So there can be many kinds of pollutants which might be present on the surface of an insulator. This kind of degrades the surface of the insulator. Now when there is rain or even moist environments, what happens is the contamination layer in the presence of moisture becomes conducting. So maybe you might have small conduction when you have a lot of pollution, a lot of contamination, but that's generally not of that much concern. But once this surface has been covered with contamination and then there is rain or a lot of moisture in the air, in the presence of moisture, this surface becomes conducting. And as a result, there will be a conducting current which is flowing through the contamination layer. It doesn't flow through the insulator, it flows through the surface of the contamination layer. Now, when current flows through the flows along the surface through the contamination layer, I square R heating is produced, and therefore a heating happens. When heating happens, so let's say this is moist and conducting current begins to flow, and when it heats up along the path of the current, the moisture will be evaporated. And when the moisture is evaporated, there might come a situation when there is moisture, and in between two moisture tracks, you might have some of the water which is kind of evaporized. So you had a conducting moisture layer and current is flowing along this moisture layer. Now let us say because of the heating, just a small region, the moisture in this region is evaporated. As a result, what you have is you have moisture, but in between the two, you have a small gap. So now you have two conducting layers, you have two conducting channels, and suppose this is connected to the high voltage electrode and this is connected to the low voltage ground electrode, which means now effectively the high voltage is available here. So now the high voltage is available here and the low voltage is available here, and there is a very small gap distance which is separating out the high voltage and the low voltage electrode. As a result, there would be a very high electric stress across this gap, and as a result, there would be a discharge which is drawn only across this gap. So this gap now discharges. There is an arc and there is a discharge along this gap. The result of that is, in this small region, you would have damage to the surface of the insulator. This region will be damaged, and as a result, what kind of damage would you have? It is not a damage only to the contamination layer, but you would have a damage to the surface of the insulator. So what might happen is there might be degradation of the surface of the insulation. So material may be completely eroded from the surface of the insulator, and then because of the degraded surface, more and more arc may tend to flow, more and more currents may tend to flow through this region. This small region will further degrade, and this degraded, so there will be channels which will be formed by erosion. So on the surface of the insulator, channels are formed where the material has been removed, has been eroded, and then further currents may flow along that degraded channel, and there may be carbonization. So what you might see is, over a period of time, you will see that black carbonized channels have been formed on the surface of the insulator. Let me show you some pictures and then I can come back to the description. So you see here, this is what is happening these are what are called string insulators. They may be made of glass or porcelain. And what you can see, these pictures are taken from the web. So just a Google search will give you these pictures. So what you see here is there are channels which are not actually, so current is flowing here, current is flowing again here, current is flowing here. The current is not actually breaching the entire electrode to electrode gap, but there are arcs being drawn along some of the, so the total path along the surface, the total flashover path is along this surface, and then traversing this, it should reach the low voltage electrode. Now this entire path is now not conducting, but only sections of these are conducting, as you can see by the brightness of the current. It's irradiating light. Now when that happens, after this happens, if you take it out, this is again a different picture, but you will see on the surface of the insulator things like this. So there has been some damage to the surface of the insulator, there has been some erosion, so the material has become kind of rough, abrasive, and also you can see some blackening of the surface has been formed. This is called tracking. This is a much better picture. This is not in an outer insulator, but it is in cable. On the surface of a cable, on the dielectric surface, you see that this kind of channels have been formed. This is a very nice picture, again taken from the internet, where you see that the channels are very clearly visible, because all of this have become blackened. So not only has there been erosion channels formed, the erosion channels are formed on the surface, so material has been eroded from the surface of the insulator, but on top of that, each of these channels have also had carbon deposition due to chemical reaction. These are electrochemical processes, because chemical reaction is in this case driven by electrical stresses. So as a result, this current forms, and you have carbonization of the material. Here, this is a surface of silicon rubber sample that we have conducted experiments on the laboratory, and we have allowed this to be contaminated, and in the presence of the contamination, we have applied voltage across this point and this point, and as you can see, over a period of time, a conducting channel has been formed, and parts of this conductive channel are more degraded than other parts, and some of these parts are blackened. So essentially what is happening is this. Firstly, there is contamination on the insulator surface. After contamination happens, if there is presence of moisture because of rain or fog, the contamination layer becomes conducting, and a leakage current flows along the surface of the insulator. When this leakage current flows, parts of this channel become so heated because of the current flow that it evaporates the moisture. And therefore, now you have small interruptions, so small gaps in the moisture film. Now, across the small gaps in the moisture film, there is a high electric stress because the conducting channel is conducting, so the voltages which were initially the conductors were far away, but part of the voltage, there is of course some voltage drop across the conducting channel, but not too much, so that across that interruption in the moisture channel, you will have a very high voltage difference, and therefore there will be a very high electric stress across the gap. When that happens, this gap may not be able to withstand the breakdown strength, and an arc will be drawn. When an arc is drawn along this small interruption in the moisture film, a very large amount of heat is generated. This heat is generated because of the sparks, and these small sparks which are drawn between the separating moisture films may irradiate so much heat that volatilization of the insulating material happens. That means from the solid, it immediately reaches its vapor stage, so the material is completely eroded and volatilized. Further, because of further chemical reactions along that channel, carbon is deposited, and so ultimately you have the formation of permanent carbon track on the surface. So this process of the formation of permanent carbon track on the surface of an insulator is called tracking. It takes a very long time to develop, and normally these tracks are zigzag in nature. They are spread over the surface. So this is the process of tracking, and tracking takes place along the surface of the insulator. Next, we will talk about tree.